My dear future civil servants, welcome to the second class of Transform CSAT initiative. I am your CSAT faculty, Sachin Gopanad. Today's topic of discussion would be HCF and LCM. Just like our first topic of discussion clock, this is also an important topic. Two questions were asked on this topic, particularly HCF in the year 2024. Okay, so now we will directly begin with the class. However, before starting HCF and LCM, we need to understand one basic concept, that is the concept of factor and multiple. Okay, now let us read the definition, let us read the examples, and then understand what a factor and what a multiple is. If a number x can divide another number a without leaving any remainder, then x is a factor of a and a is a multiple of x. For example, 2 is a factor of 4 and 4 is a multiple of 2. 15 is a factor of 60 and 60 is a multiple of 15. Okay. Now we read the definition and we read the example. Now let us understand it better. Let us take this example. Let us try to divide 60 by 15. Now we know that 15 fours are 60 and we get a remainder 0. Now look at the definition. If x can divide another number a without leaving any remainder, then x is a factor of a. So 15 divided 60 without any remainder. 0 remainder, it is no remainder. 0 is 0 remainder, nil remainder. So without leaving any remainder. Now it did not leave any remainder. So 15 is a factor and 60 is a multiple. Okay. Now let us try to divide 60 by 16. Now let us see if 16 is a factor or not. Now 16 threes are 48. Then we get 12 remainder. 12 is not divisible by 16 because 12 is smaller than 16. So 16 cannot divide 60 without leaving a remainder. It leaves a remainder. If you try to divide it further, then you will get a decimal point. I think you will get 3.75. Okay. So this 16, it is leaving a remainder of 12 when it comes to dividing 60. So 16 is not a proper factor of 60 and 60 is not a proper multiple of 16. This is the concept of factor and multiple. For example, 2 is a factor of 4, 2 is also a factor of 6 and 6 is a multiple of 3, that way. That means 2 divides 6 exactly. 2 is not a multiple of 9 because if you try to divide 9 by 2, you will get one remainder, and if you try to divide further, then you will get a decimal 4.5. 9 divided by 2, that would be 4.5. So you do not get an integer as a quotient. So 2 is not a multiple of, 2 is not a factor of 9. So this is the concept of factor and multiple. Now we are ready to understand the concepts of HCF and LCM. Okay. Now the HCF and LCM, they can be calculated for 2 or more numbers. HCF or LCM, they do not have any validation for when you go for one number. You cannot find out HCF of 1 or HCF of 2. You can find HCF and LCM of 2 or more numbers. When they give you 2 numbers or 3 numbers or 4 numbers, you can find the HCF and LCM. To find the HCF of a single number, it has no meaning at all. Okay. Now let us read the definitions of HCF and LCM and understand it better. HCF, highest common factor. The given numbers might have many common factors. The biggest among those common factors is called HCF. LCM, least common multiple. Any given numbers will have infinite common multiples. The smallest among those common multiples is called the LCM. Okay. Now we read the definitions. Let us see an example. Now let us take 18 and 24 as example. Now what are the factors of 18? That is, what numbers divide 18 without leaving any remainder? These are the factors of 18. 1, 2, 3, 6, 9 and 18. 18 divides itself. Yes, because 18 ones are 18. So 18 divides 18 itself. So these are the factors of 18. Now let us take 24. The factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. So these are the factors of 24. All these numbers, they will divide 24 without leaving any remainder. Now among these, which is the biggest? Let us see how many common factors they have. Now 1 is common, then 2 is common, then 3 is common, then 6 is common. That's all. 8, no, none of them are common. So 18 and 24, they totally have 4 common factors, 1, 2, 3 and 6, and which is the biggest among them? That is 6. So the common factors are 1, 2, 3 and 6, and the HCF is, that highest common factor is 6. So this is the concept of highest common factor. Now let us talk about LCM. How many multiples does 18 have? 18 ones are 18, 36, 18 twos are 36, 18 threes are 54, 18 fours are 72, 18 fives are 90, and the list goes on. It goes on up to infinity. So 18 has infinite multiples. All the numbers, they will have infinite multiples. Now let us look at multiples of 24. 24 ones are 24, 24 twos are 48, 24 threes are 72, 96, 120, 144, and so on. So now, do we see any common multiples in this list? In this list, yes, we have 72. Then we have 144. Yes, and if you write the multiples further, then there might be many common multiples. Here the definition says any given numbers will have infinite common multiples. So the least among them. So then there might be 288. So 288 is a multiple of 18. It is a multiple of 24 also. That way there will be infinite common multiples. However, which is the smallest among them? 72 is the smallest among them. So the common multiples of, among common multiples of 18 and 24, the LCM is 72. So this is the concept of HCF and LCM. Now we understood the concept of HCF and LCM. However, we cannot do this exercise for getting the HCF and LCM for all the problems, for all the numbers. There is a method to find HCF and LCM. Now let us see how to do that. And before trying to find HCF and LCM, before going to a method of getting HCF and LCM, now let us see some points, some notes about HCF and LCM. In the case of any two numbers, the product of the numbers is equal to the product of their HCF and LCM. So let us say there are two numbers, number 1 and number 2. If you multiply them, the product of them, that will be equal to those two numbers HCF and LCM. So this is a relation. This relation holds good only when there are two numbers. However, just memorize this one. Just make a note of it and memorize. And then this is the method to find out HCF and LCM of fractions. Sometime we might be needed to find it. In these examples, we discussed HCF and LCM of integers, numbers. However, sometimes we may need to find HCF and LCM of decimal points or fractions. Then what do we do? Now let us say you have three fractions, A by B, C by D, and E by F. Now if you want to find the HCF of them, then what you need to do is HCF is equal to find HCF of the numerators, that is A, C and E, A, C and E, and then divide it by the LCM of B, D and F. However, the condition here is that A by B, C by D and E by B, they have to be in their lowest form. What is their lowest form? I will tell you when this topic comes in a problem. I will tell you it better. So this is how we get HCF of fractions. Now how do we get an LCM of fractions? To get LCM of these fractions, what we do is take LCM of A, C and E and divide it by the HCF of B, D and F. So this will give you the LCM of these three fractions. So this is how we find out LCM and HCF of fractions. And then this point, just make a note of it, just memorize it. This I will repeat this when the relevant topic problem comes. Okay. The number of common factors of given numbers is equal to the number of factors of their HCF. So whenever there are two or more numbers, how many common factors do they have? That number, it will be equal to the how many factors the HCF has. For example, look here, for 18 and 24, how many common factors are there? 4, right? 1, 2, 3 and 6. Now how many factors does 6 have? 6 has 4 factors, 1, 2, 3 and 6. Because 6 is divisible by 1, it is divisible by 2, it is divisible by 3 and it is divisible by 6. So these are the 4 common factors of, 4 factors of 6, and they happen to be the 4 common factors of 18 and 24. So just make a note of it. it is okay even if you did not make a proper sense of it. You will understand it better when we solve a problem based on that concept. Okay. For the full lesson, join the course. The link is in the description. The best thing about the course is that it costs only rupees 299. Thank you, all the best, and most of all, happy studying.